All right, welcome back. Today we're going to be talking about section 3.6, the application of linear functions. Now, this entire chapter we've been talking about lines, right? Things that form lines, things that have a constant rate of change. But we just dealt with the skill-based form of linear functions. But now we're going to take those skills and apply them to real-life situations. Okay, so if you have not grabbed a highlighter from the front drawer, if you can grab maybe two or three colors. Okay, good. So now I'm just going to break down a word problem, basically. So now I broke this down into basically a sentence of what something is going to be asking. It's going to have me problem solve. Okay, and it's going to have me write an equation from a situation to problem solve. Okay, so good. Now, I'm going to pull out important information that I need. Okay, so this one says, suppose that a water level of a river is 34 feet. So we're looking at a river. The level right now is 34 feet. Okay, 34 feet. So that's important. The level right now is 34 feet. Good. And that's another important word, that it is receding. Okay, receding at a rate of 0.5 feet per hour or foot per hour. Okay, good. Now, that whole situation or that whole statement is important, and I'll explain why. Okay, so now that I kind of pulled out the important information, I want to go ahead and translate it algebraically to numbers, okay, and operations and a variable. Okay, so the level right now of the river is 34 feet. So um, part A, okay, part A is asking me to write an equation. It's asking me to write an equation in terms of L after D days. So write an equation for the water level. So if it's asking me to write an equation for the water level L, it's asking me for an equation that has L equals. Because what does the level equal after the days change? Okay, so L is the same thing as saying Y. D is the same thing as saying X. But in this case, I don't want to use, change that. In this case, I don't want to use X, I want to use D. Okay, good. So now let's refer back to our situation. So the level of the river right now is 34 feet. That's not going to change. That's what it's going to start at. So it's like our starting value if we're talking about a y-intercept. Okay, so it's going to be 34. Okay, good. I'm going to skip the word and, excuse me, and I'm going to come back to it. Okay. Now, it is receding. Okay, receding is important. Receding at a rate of 0.5 feet or foot per day. Okay, receded. Receding means to lose. So you're usually going to get an important word in a linear application problem, something that means to either gain or lose. So you could see growth, you could see lose, you could see increase, you could see decrease. Those types of words mean to gain or lose or add or subtract. So receding means to take away or lose. So I'm going to take away how many feet per day? 0.5. Now, what's changing here? Am I saying after 3 days, after 4 days? I'm not. It's just saying per day. So that's going to change for every day that happens. So in this case, it tells me to use D for day. So I'm going to use the variable D. So 0.5 feet per day, it's just going to be minus 0.5 D. Okay, good. Now, the word and means to combined. So if I wrote plus here, okay, I start with 34 plus I'm losing 0.5 feet per day. So if I have plus and minus, the same thing is saying subtraction. So now that I have all my information algebraically, I'm just going to rewrite it. So I'm going to write 34. Now this is saying plus a negative, which is the same thing as saying subtraction, 0.5 t. Awesome. Now, that's the same thing as saying if you wanted to write it as y equals mx plus b, that'd be the same thing as saying y equals 34 minus 0.5x. It's like saying the same thing, okay? But this is using a notation in terms of the problem. Good. Now, it's asking me to answer a question. In how many days will the water level be 26 feet? Now, what's given? What are they asking? Okay, what's given? What are they asking? Okay, well, how many days? Well, that's what they're asking. Days, right? In this case, I'm looking for D. Okay, and what's given? 26 feet. Okay, 26 feet. Good. Now, I'm going to take that 26 feet and I'm going to plug it into where it is in my equation. So 26 feet represents the level. Okay. Well, where do you see the level in your problem? It's simply L. So I'm going to take that 26 and simply plug it in for L. So it's going to look like 26 equals 34 minus 0.5 D. Okay. Now that looks like a simple equation, multi-step equation that we've worked on for weeks. So the first thing you want to do, if you want to draw your river, okay, subtract 34 from both sides. Subtract 34 from both sides. I'm going to be left with negative 8 equals negative 0.5 D. D. Okay. Good. Last step, I'm going to divide both sides by 0.5, negative 0.5. And I'm going to be left with negative 8 divided by negative 0.5 is 16. So that cancels out, and I'm left with D. But what does that mean? 16 equals D. Well, simply, all I'm going to do is take that 16 and apply it to the problem. What did it ask me? Excuse me. It said to me, in how many days, D, 16, will the water level be 26 feet? So when I go ahead and write an explanation, okay, I'm going to say, after 16 days, the water level will be 26 feet. Okay. Awesome. So now when I go ahead and answer another question, I'm going to want to write it in a complete sentence if there was a part C. Okay, good. I'm going to go through one more example, set up the equation for you, and then I'm going to have you solve for part C, and then the following problems can be money problems. Okay, so now, let's grab our highlighters again. Now we're talking about a babysitter. So we're talking about a babysitter named Nicole. She charges a flat fee. Flat fee is important. Of $3. Good word. Plus, okay, $5 per hour. So we just pulled out our important information. Now, say you want to hire Nicole. All right, you want to know how much she's going to cost. Okay, so in this case, it asks us to write an equation in terms of cost. So it says write an equation for the cost state. So my equation is going to start with C equals. Right? Now, if I talk about a flat fee, no matter if she babysits for an hour, 4 hours, 5 hours, 6 hours, no matter how many hours, she's going to charge $3 for basically stepping in the door. Good. Now, I'm going to say plus, obviously, is addition, $5 per hour. So that's going to constantly change for every hour. So I don't know what the hour is. In my problem, it says use H as the hour because that's going to change. So all I'm going to write is 5H, like that. Okay. Now the hour is that's going to be costing. So that's going to be addition. Okay. It's going to be accumulating. Good. Now, once I have my algebraic expression up there, I'm just going to bring it down, and that's what C is going to equal. So it's going to equal 3 plus 5H. Okay, awesome. So that's my equation. Now, letter B is unique. So I kind of broke it down in a last question. So if I have C equals, that's the same thing as saying Y equals what? 3 plus 5 instead of H. It's just the same thing as saying X. Okay? So now looking at that, type of equation. It's in slope-intercept form, as we know. Okay, your slope is the number that's always next to x, and your y is always going to, or your y-intercept is always going to be the other number. Okay, so the question that just asked me, what is the slope? What is the y-intercept? In this case, my slope is going to be what's changing. What's happening per hour? It's going to be 5. Okay, and what's the intercept, or the y-intercept? It's going to be 3. Okay, so if you're talking about words, the 3 is the starting value. That's the initial value. Okay, and the $5 is per hour. Okay, or rate of change. Remember rock? Okay, good. Now, I want you to go ahead and try to solve for C. It's asking me now, what is it asking? What is it given? Okay, how much money? How much money? I don't know how much money. That's what it's asking. Okay, will she make if she babysits for 5 hours? That's what's given. So when I go ahead down here, excuse me, I'm going to go ahead down here, it's what's given, 5 hours. Okay, what is it asking? How much money? So it's asking for the cost. Okay, good. Now, what I want you to go ahead and do is solve for C. Call me over. I will check it, and then I want you to try number 3 as a money problem. Good luck.